No, I've been known to levitate like a hobo trying to catch a freight. To get away and clear the day, then I'll be smiling at the stars like the hood does cars. Little ghetto mind, you should travel like a bullet from your favorite gun's barrel or the Indian's arrow. Mathematically aligned like the pyramids of...
Problem 2980 requires the use of Coulomb's law to solve for these charges. There are two positive charges, and as such they repel each other, and therefore they are some distance apart. Let's call this distance r. So here we then have r over 2. Let's call this the length of the string L. And here we have angle alpha, 26 degrees. So from here we can say that sine of alpha is r over 2 divided by L. And solving for L, r, distance is 2L times sine A. Let's see what kind of forces are acting on one of the charges. So here we have the charge Q. It is being pulled down by gravity, mg. Then there's some Coulomb's force pushing it to the left. Let's call that Fc. Then it's suspended on a string. So there's a tension in the string called T that keeps it from falling down. And we have some angle here. Let's call that theta. We also know that here we have alpha, from which follows, because this is a right angle, the theta is 90 minus alpha, 90 minus 26 degrees gives us theta of 64 degrees. Because the charge is not moving, the forces in both x and y directions must cancel each other. And in fact, this force, the tension in the string, can be divided into two components. So here we have T in x direction, and here T in y direction. So first let's consider the forces in the vertical y direction. So we see that Ty must be equal to the gravity mg. What is Ty? Ty, it's just a cosine, sine of the actual tension in the string. So we can write T in y direction is T times sine of theta times mg, which allows us to solve for the magnitude of T, mg sine over theta. In x direction we have that the Coulomb force Fc must be equal to the x component of the tension in the string, Tx. What is Coulomb's force? It's k times q1, q2 divided by the distance between the two. In this case, r, and the distance squared. And Tx on the other hand would be this component, so it's the cosine of actual T times cosine theta. So what is T? We know from here. Okay, let's repeat this. Q times, okay, Q1, it's here. and here's Q2. So we see Q1 is Q over 2. So we have Q over 2 times Q over 2 divided by R squared. And now plugging into T from here, we get mg divided by sine theta times cosine theta. And rearranging, k times q squared divided by 4r squared equals mg, and sine over cosine is tangent of theta. And we want to solve for q, so let's first have q squared is 4 times r squared times mg divided by k times tan theta. Taking the square root gives us q is square root of that is 2r square root of the whole thing, k times tangent theta. Now we're ready to plug in the numbers. Let's give some space. So q is, alright, first of all, what is r? R is 2l sine theta. So let's make that substitution. So we have 4 times l times sine alpha, not theta, sine alpha, mg divided by k tan squared. Okay, I'll fix this. We have 4 times L, 78 centimeters, times sine of alpha, alpha is 26 degrees, square root of mass. The mass of each of the bobs, 24 grams, 0.024 kg, times 9.81 meters per second squared. And k is constant, 9 times 10 to the 9 Newton meter squared divided by Coulomb squared, and tangent of theta, which is tangent of 64 degrees. So here we have, if you look at the units, kg times ms squared is Newton, so the Newtons cancel, and we are left, in fact, square root of c squared divided by m squared, which is c over m in this expression. And when we multiply by this meter, this will cancel and we are left with coulombs. So we have got our correct units. Okay. So if we plug in these numbers, we get 4.9 times 10 to the minus 6 coulombs. And that is the total charge in this question.
Like a missing puzzle piece, make completion hard to find. I was resuscitated by Capri Sun juice packs. Woke up singing nerd songs and you can YouTube that. Now stay away from people in pursuit they lack. And remember